Margaret, for organising today. So this is some work done with colleague Mike Brayshaw here at Hull. Again, it reflects some discussions we're having in the computer science community, nationally and globally, about the impact of AI and what we teach, which echoes many of the points from the previous speaker. So, looking at some issues we've got, the challenges of generative AI is having on computer science education. Some issues here are particularly because of the way that AI is very applicable in things like teaching programming and in creating software. I'll talk a bit about why that seems to be the case. A bit about the fact that we can see students are already doing this, which then echoes some of the points of the earlier talk about the ethical use of these things. And again, looking at some of the platforms now. So obviously there are the explicit ones like ChatGPT, Bard, or Gemini, Claude, and the integrated tools as well. So like Copilot, which is appearing both integrated into general environments like Office. You may see it yourself, you're using like Edge for web searching. You've got a Copilot sidebar appears, which will attempt to answer questions for you. But also particularly into things like Visual Studio, Idle, and other program environments, where you can integrate the AI in a way that means it's supporting the developer. But it raises all sorts of challenges in terms of, well, what do we need to teach developers? One of the ideas looking at in the talk is looking at the human side of entity development. What is it we should focus on as educationalists in computer science? And looking at getting the human then to maybe look at finding solutions that are optimal, safe, and secure that you won't necessarily get if you just ask an AI system for a code solution. And so we're looking at the way that what we mean by optimal to a human is different to what it would be to an AI without the right prompts. So again, the sort of runtime resources and the wider impact of that. Again, with AI systems, they're great and we seem magical, but there's a big cost to them. And the growing concern is the energy cost. This is an e-learning meeting. I think the green computing one might also look at the issues we're having now from AI. These large language models burn a lot of energy. And currently, we don't have renewable energy to supply all that. So we are creating carbon footprints by doing a search on an AI system. Integrating AI into Copilot, we're generating a lot of carbon currently. So there's lots of ethical use of this. So for sort of wider context, and I think a lot of it's covered in the previous speaker, these systems are changing many parts of society and human work. I think computer science is particularly prone to this, partly because obviously the underlying models that these AI systems use, they map well onto the technologies we use as computer scientists, as programmers. The way we develop and create a large language model for programming, the stats involved in that, they echo the programming and the computational science that underpins programming in general. It doesn't mean we can use generative AI to solve many computing problems. We can do it efficiently, effectively, quickly. And that then is a question of, well, what do we need humans to do? So if you want to create a sort routine, write a computer game, create a website, you can do it now in a few lines of query to one of these generative AI systems. So the question becomes, well, what do we need a human programmer to do? What's the value added of making someone do that if an AI system could do it quicker, more efficiently, and let's see, debatable point is better or as good as. And then from an educational perspective, what do we need to teach our new programmers? So we used to go to Programming 101. It's evolved a little bit over the years, but I think fundamentally things like iteration, branching, variables, these are concepts that have been common since early programming languages. And a Programming 101 course today, the syntax and platform may differ, but the principles often are very similar. And the question is, how appropriate is that in the age of these AI systems? So I'll go through some of these points now and say there's a apparently discussion points, not like giving definitive answers, just saying here's some of our experiences here at Hull. We're using some systems, we've experienced the challenges we're creating. So in terms of general programming AI, I'd say generative AI seems particularly effective at many programming activities. Again, the last year or two, as ChatGPT began to appear as a general purpose interactive system, beyond asking simple questions in English, very early on, try to answer the questions about programming. Write a piece of C# code that will sort a list. Write some Java to rotate a triangle. And it will give you the correct answer. That really helpfully, from a teaching perspective, it will actually explain the answer as well. So it does more than just give you a code answer. And again, looking at the background of this, we've trained ChatGPT, Gemini, Claude, on things like Reddit, on GitHub. They're learning from the vast collection of repository of code that's out on the internet. And if you give it a problem, it can find it and give you an answer by amalgamating that consensus of code on the internet. And equally, whilst the systems are good at simple problems, they're improving on more complex ones. And we're seeing that because the companies like OpenAI, Microsoft, Google, that are creating these systems are working to make them better. So one of the key ways of doing that is also by creating feedback loops. So these feedback mechanisms, meaning AI can learn from what users say, that was a good answer, that was a bad answer, that code was good code, it was bad code. It can learn from that and improve. So again, saying, well, today that program, it's okay creating a simple bit of code, but ask it to refactor a program into an OO paradigm, it's not very good. But often it's because we're looking at the current state of the art today, not what's going to be state of the art in a year's time. And sometimes we give the wrong prompts. And people say, well, if I give it some code, ask it to write tests for that code, the tests are independent of it, they're using the code. Well, that's true if you gave it to a programmer, said, here's a code, test that code, they'll use some knowledge of a code base. If you want to write better tests, you give a spec and say, write tests based on the spec. So the prompts people are using are sometimes wrong. And so the question becomes, through simple routine tasks, these systems can, and again, one of the more debatable questions is, perhaps they should replace humans. So why are they so good at programming? And again, a caveat, but these slides, and some of my slides later talks, these came from Copilot or Claude or other AI systems. So we'll say that. So that's Claude and ChatGPT. Why are they so good at programming? Again, I'll get the answers from those two platforms. But again, they highlight the things you'd expect to say as a computer scientist. They're good at pattern recognition, and programming is full of common patterns and structures. In software engineering, we teach design patterns. These systems are much better than humans at spotting patterns and using them. They understand natural language, so we can give them instructions in a more human-friendly way. They can understand that and generate code. And in that sense, they're probably not really much worse than if you give a user requirements to a programmer, particularly a student programmer, a novice programmer, ask them to understand those requirements and write code, they'll get it wrong. They're going to be very good at that context awareness for code. They can suggest code completion based on where you are and support multiple languages. You can ask it to solve something in Java, ask it to then convert that or solve it the same problem again in C#, and it can do it. And as I said on the previous point, on the previous slide, the iteration of this, they can learn from getting good feedback. So the models were trained originally, things like large language models, using machine learning. They apply that at the point where they're being used in practice. So Copilot, ChatGPT, as you're using them, many of them have the potential to give positive or negative feedback on our answers. So they're developing. They're also very good at things like bug detection and correction as well, because they're not as prone to the sort of clerical errors, the reading errors we make as humans. I think there's an estimate that humans on average make something like 6% of errors in clerical tasks. So if you're writing a program, chances are that you'll make 6% of the time you'll be doing some sort of error by maybe putting a plus sign to a minus sign, mistyping something. Some things compilers will identify, many times they won't. Whereas these systems are very good at analysing code, refactoring it now. Again, they're getting better at that, more complex tasks. And for things like bug fixing, we're getting good as well. And we're seeing the students are using this. So Higher Education Policy Institute here in the UK, the Codio company, an American company that have a programming platform, and many universities here in the UK use that platform. We don't hold them, we have a bespoke one, but it's similar. But they've done some research with students using Codio, computer science students, particularly in America, but reflects the same experience we have here in the UK. And students attend to AI because they see the benefits in terms of efficiency and outcomes. And again, how far that's ethical, how far that challenges academic integrity, and goes back to the previous talk. One thing for programming is in these systems can produce runnable code that solves problems very easily. So it gives students a way to quickly do things with a mental block. They've not understood something, give them a problem, and they can solve it. One of my colleagues here at Hull, he gave ChatGPT his sort of programming 101 course equivalent, the problems he sets in labs. And ChatGPT currently could answer 70% of those. He did what would normally expect to take students several hours. Again, he knows the prompts to put in, but he was asking it the prompts to solve his problems, write some code, and he could do it in 5 or 6 minutes. So we have to be aware that students understand that potential benefit. And equally, when we go into the world of work, they'll be using these systems. We've talked to colleagues in industry, both in technical areas, and programming, and more general industry use. People are using more and more of these platforms. There's some limitations of them. They're aware of some of the challenges they create in terms of IPR, who owns the code if you use the tool, but it is happening. Let's say with several platforms, we have general purpose ones, so like ChatGPT, one of the most famous one people are used to, with things like, say, Gemini that Google use, the Claude platform, seems particularly strong in terms of both its coding ability, and they've also, I think, good line ethics that they've applied as a company. In these, those students are clearly using AI, they're aware of it. Again, it goes back to discussions we had at the end of the previous talk. But of course, they can download or copy and paste that content and use it elsewhere. There's integrated versions. There's things like in Office now, they're integrating Copilot. So not the programming version, but the more general purpose version. Google Docs, the beta version had it. I think the full version will have it soon, has got Gemini built into it. And again, obviously, I was in some search engines, as I mentioned earlier, in Edge, if you're searching for things, you can get the answers that Edge will find for things like Bing in terms of a search engine. You'll get AI, so just an answer as well. And if you've got the Copilot sidebar turned on, it will give you a different answer there again, or generated by different AI systems. And in programming platforms, we're seeing this now being integrated more and more. They can be separate ones, and again, there's several programming tools now. There's a few that utilize APIs to connect to things like Copilot or to Claude, and you can get them to solve programming problems. And more so, from a CS perspective, the integration of them now. So Visual Studio, where Copilot now is integrated into it, so you have a sidebar which understands programming, understands what you're doing and the language you're doing it in, and will autofill code for you. You can type in an English type description. I need a class that will do this, solve this problem, and it will suggest one. Or you can see the code you're writing and suggest auto-completion beyond what the normal IntelliSense would do, but actually saying, here's a block of code that solves this problem. I think you ought to sort a list. Here's some code that will sort a list. So sorting is a good example of where we say, well, how far does students need to understand sorting anymore? Again, kind of programming algorithms course we might do would be talking about efficiency and searching and the need to improve searching. Again, when I was a student a few decades ago, that was really critical. Computers were quite slow, memory was a big issue. We would spend time learning about the issues around having a list, how you sort that list, what's the best way to sort a list? Is it binary, bubble sort, here are algorithms, here's complexity of algorithms. This thing might take twice as long, and if that twice as long might move something from being 1 hour to 2 hours of running time, that matters. But how far now do students need to know that? For libraries, it will do sorting. If you're teaching things like, again, we use C# here at Hull, but in Java, similar thing. There are perfectly good component libraries that can do sorting. Why spend time teaching students to sort? What's the benefit of that as an end developer or for users when the library can do it for them? So what's optimal there in terms of the runtime and resources? Does that matter now with the speed of computers, the availability of resource? So suitable, the search routine might depend on the data being sorted, the platform is running on, the size and location, but we can do that by libraries or by getting the system to do it. So this is traditional computing curriculum. I asked ChatGPT about 10 bullet points of typical university computer science curriculum. And again, I think it matches things we'd see in many courses. I was quite of other institutions. The introduction to programming, data structure algorithms, computer architecture, operating systems, databases, software engineering, discrete maths, computer networks, AI, machine learning, and infinite computation. So these are things we teach a lot of, the common. They spent at A-level. The A-level syllabus now is much like this as well. Maybe slightly less depth for some of it. First year programming, second year programming covers many of these topics. But many of these things can now be automated by AI. To what extent do we even need people to understand them in detail en masse? We need some experts, but how many experts do you really need? Because it's white boxes, there's black box approaches. To what extent are we going to think of programming more like an information system? Data in, you do something, information out. So software software engineering is another approach where we do something similar. We say to students, here's how you use component programming. These components do what you require. Here's the interface, make use of it. They don't need to know what's happening inside that component. And we can start to do more and more of that with AI. So educationally, the challenge becomes how much developers need to know to understand those hidden workings. And I think the answer there from my perspective, again, echoes I think the previous talk, is focused on the human here. Focus on requirements humans have to solve problems, looking at things that are optimal, secure, and safe, which you won't necessarily get if you ask a ChatGPT or Claude to write some code to do something. Think about the impact of poor code on resources, runtime, and thereby the environment. Think about user-centered design, so things that take account of the people that will use it. And think about the whole life cycle of software. So, but we've got to think about the methodologies, processes that do that, how AI helps in that process, how can make it more efficient. But if we replace all of the human knowledge by AI, then there's no one with oversight of it. It makes it harder to then deal with it if there are problems. So how do we link AI with software engineering from that perspective? Look at the life cycle of software and think about where we put in the human. So things like AI in design, like game narratives, running computer games, AI and user experience, like user-centered design and engineering, building software for people ultimately. And again, looking at how analogy looking at statistics, there are many tools which will solve stats problems, many people use them, but it's know how to use those tools, not necessarily to understand the intricacies of the stats, but make SPS do hypothesis testing. So maybe areas for future computer courses and for our students going forward. Look at human understanding, intuition to work with users. Think about requirements beyond what users might just ask for. So ChatGPT, Claude will give you exactly what you require. As a user thought of all of that? As experts, as developers, what can we add into that knowledge base? Give it expert analysis and oversight to review a solution as well. Is it a good solution? Is it appropriate? Think about testing and evaluation. Again, in a way that AI will give you some tests, but they may not be appropriate tests. And look at security. There's a good way to build systems which are built on available software approaches, which aren't secure. And then that certification of software solutions, which again, a human can add in, looking at what the AI has created to validate that it seems appropriate and efficient and thinking about also, ultimately also the ownership of this, the IPR. That's one of the big challenges where you choose AI to generate code. Where did it come from? If it learned a solution from Reddit and Git, if it then gives you a piece of code that looks okay, is it appropriate? So think about the skills that we teach our students. We kind of think about more the general skills we teach in computer science. So we can teach problem-solving approaches, how you break down problems, how you understand it. Another question becomes, how far does CS become a general problem-solving degree, and how far is it still a vocational one, creating developers? Is it creating a career pathway for people, or is it going to become more like many arts subjects currently are? It gives you good graduate skills, but chances are when you go into your future, you won't be applying the direct knowledge you've used, because in programming terms, the AI is making that. So the future of this, the last minute or so, future of this is looking at this, how much does a new programmer really need to know? How far do you still need the old advanced algorithm sort of courses? How far do we understand things like complexity? How far do you understand how to write simple code when AIs can do that for them? And what are the intellectual concepts we need to carry over that really are key to our students in the future? So computer science may morph away from that highly practical engineering discipline to one that's more done for students who want to understand what's happening inside these black boxes. Also about the fun sides of CS and what we do with that, the intellectual skills it can develop, the value added it gives. In the same way, of course, compilers teach students the principles of building a compiler. Most will never write one, but use available compilers, they'll buy them. How important is it that we give them the fundamental knowledge of computing alongside the ability to build software when these black boxes, these AI-driven systems now, can solve them so easily? There will still be need an ongoing technical requirements for people that are technically proficient but skilled computer scientists can oversee this coding, but it might be a much smaller number. And again, that's one of the challenges that many of the disciplines have in physics, chemistry. How many skilled physicists do you need? Many people have those degrees gone to other careers, economics, banking, etc., because of the underpinning knowledge they have. They don't want to become advanced physicists. So maybe some of computer science going forward, the pool of required computer science experts will decline, but the applications of it will grow. And at that point, I'll stop there. Thank you.
That's it? Thank you. Any questions?
Cecilia, there's a few in the meeting chat. So I think, Stanis, first question about what skills will employers expect. I think growing one will be that ability to work alongside AI. I guess making effective use of AI, understanding its limitations. Again, I think things you covered earlier partly, but AI systems will hallucinate, they will get things wrong, they won't make the best solutions. So I think employers will increasingly expect our students in particular from computing to be skilled and able to utilize AI effectively, to give advice about this system is okay, but here's a warning about it. So yeah, I think there's going to be an increasing look on that. Put increasingly focus on the interface from humans to AI systems. So we've had it in the past where people like IT system requirements analysis is a bit of what we do, but often it's quite small. We spend a lot of time looking at programming, developing systems, writing code, using UIs, using file systems, using databases. So the vast majority of that in a few lines of code, you can do it now in AI. I can remember, I don't know how many of you sort of my generation or so, but I remember playing text-based computer games a few years ago. I wrote one for our school activity the other week with 4 lines of English. Asked ChatGPT, create a text-based computer game like Colossus Cave, base it on University Hall campus, have 10 locations for students to explore our campus. And it gave me a computer game. You can get a similar thing if you've got one of the systems that supports graphics more, ask it to create a computer game based on this. In 2 lines that you can do it. Again, many systems now, if you've got the ChatGPT Plus, upload a spec, ask it to create a website, they can create them. So the technical skills we spend so much time on, the AI can quickly do. Refining that output, I think, is where the value will be. I think that the key thing will be getting people to use an AI efficiently and then understand the limitations and constraints of what it creates to then make the bespoke, polished requirements you have later on. And I think, I'm going to go on to Ellie's point. Yeah, I agree. I think the human intuition is going to be a key thing because that's a value added we have over the AI. They are, again, I think it's been the unfortunate thing is it's called intelligence. These are not intelligent systems. They're predictive systems. And I think as predictive systems, they're great and can do all sorts of really helpful things, but they're not intelligent. And I think that's again a philosophical perspective. There was a talk yesterday the BCS had about ethics, and there was a lot of debate then about are AI systems intelligent or not. The personal view is they're not. They're predictive. Certainly, generative AI systems are based on stats. It's maybe emulates what we do as humans, but it's not the same. And so our human intuition, our human values are where we can really have a role to play alongside our new, very advanced tools, which are driven by AI. Thanks, everyone.
Yeah. And when the systems fail, for example, like the post office, that's what came to be known as the scandal, someone's responsibility, so you cannot blame the AI. Someone in the end has to sign for it and take the responsibility.